All right, welcome to today's user group meeting in Azure User Group Norway. Today we are going to have a talk about Azure Virtual WAN with Derek Smith. He works as a Cloud Evangelist at Trace3, and as part of the Cloud and Azure team, he engages with clients to help transform their business applications, operations, and initiatives to the Azure Public Cloud. He also regularly serves with the Azure Community as a mentor, public speaker, content creator, and enthusiast for all things Azure. Last week, he also was attending a podcast at cloudskills.fm about cloud evangelism, getting started with social media and managing the chaos. I thought it was a really good episode with a lots of tips and tricks, so feel free to check that out. I can post the link in the chat afterwards. Before we get started, I also wanted to mention that today's user group sponsor, Microsoft Norway, they have this Microsoft Learn that you might have seen before, with a lot of opportunities to go through different modules to learn about the various topics. So if you look into the networking section, you should find something related to today's topic as well. Also, we have competition for the best tech question today, so feel free to ask questions in the chat or unmute yourself and ask questions, and at the end we will pick a winner for a backpack. So with that, I will stop my presentation and hand it over to Derek, who was kind enough to join us to present for us today, and he actually got up at 4 a.m. this morning at his time. So thank you very much for that, and take it away, Derek.
All right, sounds good. Thank you. Greetings, everybody. Let me switch over to my PowerPoint here. All right. Hopefully everyone can see my screen okay. As John said, my name is Derek Smith. I am a Azure Cloud Evangelist working at Trace3. It is my role here at Trace3 and just my general role that I love doing on a daily basis to meet with fellow Azure community members like yourselves to talk about all things Azure. My background is traditionally in networking and security before I transitioned to working with Azure about 5+ years ago. So naturally, one of my more passionate things that I work on within Azure today is Azure networking and Azure security. So the awesome benefit is Azure Virtual WAN touches on both these topics. So one of the things that we look at when it comes to connectivity within Azure is there tend to be a couple of different connectivity options within Azure, these being virtual private connections, point-to-site VPN connections, and ExpressRoute. And there's a number of different limitations when it comes to implementing these independently that don't necessarily scale well when it comes to an overall enterprise type design. And it becomes somewhat of an operational challenge when we look at each of these individual connectivity options. Not all of them are under the same operational purview when you look to troubleshoot, set up, configure each of these different connectivity options. So a lot of organizations have some struggles when it comes to an operational model with these various networking technologies. And ultimately, I think everybody's kind of heard this phrase, right? Blame the network. Oh, it must be the network. There's something slow going on with the network. And troubleshooting has certainly gotten a lot better within Azure over the last couple of years with Network Watcher and some of the additional technologies within Azure Monitor. But it's never been, I think, something that a lot of Azure professionals can say, hey, with the definitive design that, you know, the network is perfect, up and running. And so we tend to require some additional tooling to kind of help troubleshoot those capabilities. Also, in the last couple of years, we've started to see more of a software-defined shift within a lot of enterprise clients. They're moving away from the traditional networking model and moving to this more software-defined networking or software-defined WAN capability within their own organizations, and leading those organizations to have the capability to make WAN type changes on the fly via code instead of having to purchase new hardware, set up new network connections, things of that nature. And so with this software defined shift also comes obviously this implementation of a zero trust network security capability. As more applications are being put out there by a lot of organizations, there's been this need to define a new network security boundary for a lot of these applications, as well as just organizations as a whole, to adopt this zero trust model. And that's ultimately where Azure Virtual WAN can come in and help simplify a lot of this for various organizations, because its ultimate vision when Microsoft announced this technology was to bring together the various networking, security, and routing capabilities under a software-defined WAN as a service within the cloud, leveraging their fiber backbone. Now, just a brief overview of Azure Virtual WAN. Here are kind of the 5 pillars that we commonly identify with the Virtual WAN service. You've got your various connectivity options. You take advantage of that global transit architecture. You can secure the Azure Virtual WAN Virtual Hub. It has built-in dynamic routing capabilities. And then the last one, which is a relatively new feature, you can integrate a network virtual appliance within the Azure Virtual WAN Secure Hub. And we'll talk about the 2 third-party options that you can leverage within that. Now, the important thing to understand within the connectivity option, it supports all of those 3 primary connectivity options we talked about earlier. So site-to-site virtual private networking, supports IKE1 and IKE2. There's a lot of partnerships that Microsoft has made with various providers to automate VPN connectivity capability. So if you have something like a Fortinet or a Cisco or a Palo or a Checkpoint, they all have an automated way to set up VPN connections with Azure Virtual WAN. That make it a very zero touch or at least low touch type of design when you need to add various branch or small office locations to your virtual WAN setup. It also has a greater scale capability than your traditional virtual network gateway that you find from a VPN perspective. It can scale up to 1,000 connections per region, whereas your traditional virtual network gateway caps out at 30 connections per virtual network. And now there is a throughput cap at around 20 gigabits per second. That is aggregate per region. Basically just saying the network ISP speed that comes into the hub caps out at 20 gigabits per second. Now you can scale up from 500 all the way up to 20, but 20 is the limit. So it's a planning decision that we all have to make as Azure architects when we're setting up our various hubs. And hubs are tied to Azure regions, how much throughput capability we need in each of those regions. And some of the new features they've added with site-to-site VPN are fully qualified domain name-based IPsec, as well as a custom BGP. Now, within the point-to-site VPN arena, this one's grown a little bit larger because of the pandemic and in response to what had happened about a year ago. They've scaled up point-to-site VPN. I think the original limit was about 10,000 users per region. They increased that to 100,000 users per region when a lot of us shifted to a more remote work or work from home setup with a lot of our organizations. In addition, they increased that capacity from 20 gigabits per second aggregate to 200 in response to the pandemic. Now, point-to-site VPN does have a built-in traffic manager that you don't see from a operational standpoint. However, it is in the backend and it's integrated directly with the Azure VPN client. So as you deploy point-to-site VPN within Virtual WAN, there is a traffic manager that load balances all of those users who are connecting to the service and will automatically direct them to their closest region or point of presence within the Azure fiber backbone. One of the new features they've added is the ability to apply custom DNS servers. So if you are configuring this for your client or configuring this for your organization, you can now specify custom DNS servers. So if you have DNS servers deployed within your Azure environment, or maybe you're leveraging something outside of Azure DNS, you now have that capability to direct DNS traffic to a custom endpoint. And then finally, ExpressRoute connectivity is also included within the Virtual Hub capabilities. It does support encryption with a VPN tunnel or directly over that ExpressRoute connection. Again, 20 gigabit aggregate throughput per ExpressRoute. So it's not an ideal situation if you need something more like a 40, 50, or 100 gigabit ExpressRoute connection. Typically, those are found with ExpressRoute Direct or ExpressRoute Local. So if that's your situation, I would still recommend using the traditional ExpressRoute gateway versus Virtual WAN. However, for ExpressRoute connections that are maybe 1, 2, or 5 gigabits in speed capability, Virtual WAN is an ideal situation to go ahead and connect those ExpressRoute circuits directly to your regional hub. And just as I mentioned, these are some of those strategic partnerships that Microsoft's made that integrate well with Virtual WAN. So your Checkpoints, your Barracudas, your VMwares, your Palos, your Ciscos that you can all leverage. And now when we talk about the global transit architecture, we truly do mean global. It's a fully meshed hub. It supports any-to-any connectivity, and that means any region to any region. So take, for instance, if I were deploying a virtual hub here that's close to my region, so Eastern United States, so I could pick East US or East US 2, and I can easily transit to, say, a region close to where all of you are. So I could choose something like Norway or North Europe. All of that is handled automatically, right? So those two hubs that, say, I were to spin up in each of these regions, they automatically get connected in the Azure backend. And so I can support a branch to Azure or branch to branch type of connectivity, irregardless of which connectivity model I use. So whether it's point to site, or ExpressRoute, I can reach any of those Vnets, whether they be in my local region or one of my remote regions. Seamlessly, it doesn't even appear to your end users or your clients as if you're transiting to a different region. Now, one of the main benefits of Virtual Hub is that transitive routing capability. There is a Virtual Hub router built in directly to your Virtual Hub, and it controls the routing between all of the various gateways within the Virtual Hub, as well as that VNet to VNet transitive routing capability. That VNet to VNet has about a 50 gigabit aggregate throughput per region. The only quirk to this that a lot of us don't necessarily always take into consideration is out of those 500 virtual network connections that we can make to a hub, you have to subtract the number of hubs. So if I have, say, 5 hubs in my virtual WAN, I can actually only support up to 495 virtual network peering connections. So something to keep in mind if you're looking to spin up your own virtual WAN. I doubt you'll ever run into that specific limit, but it is something to keep in mind if you work for a very large organization and you need to connect, quite a few hundred virtual networks to your virtual hub. Just be mindful of that limit when it comes to a routing capability. Now, additionally, you have a custom routing capability that you don't find within a traditional Azure sense. I know a lot of us are used to those user-defined route tables or static-defined route tables. Azure Virtual WAN has the capability to actually be more of a dynamic routing solution. You can develop a custom routing table specifically for your virtual networks, and you can actually propagate routes that are learned from other virtual networks or your on-prem connections, or what Azure defines as your branch connections, so point to site, site to site, or express route, and automatically propagate those connections into those various route tables. Now, each of those tables can be associated to various virtual network connections. And you also have the ability to go in and view the effective routes on the various route tables. So I know traditionally within Azure, they have the option to go in and view the effective route table on, say, a virtual network interface. Similar concept. However, this is done at a route table level versus a interface level. Now, within the Azure Virtual WAN Hub, we can bring security now directly into that hub. This was not something that was initially launched with this service. It was added roughly a year later. You can secure the virtual hub with the Azure Firewall, getting all of the normal Azure Firewall features directly into your virtual hub, or you can use one of the 3 security as a service partners that Microsoft currently leverages with the solution. Those partners are Zscaler, iBoss, and Checkpoint. Now, all of those firewall solutions are managed through Azure Firewall Manager. So you'll define your security policies within Firewall Manager and apply them to the various secure virtual hubs that you might have within your organization. You can apply any of those policies across multiple firewalls, multiple regions, subscriptions. It really doesn't matter. It just depends on where you need those policies applied, whether it's securing internet-bound traffic or private-bound traffic. And then finally, we have our newest addition to the Azure Virtual WAN service, which is deploying a network virtual appliance directly in the virtual hub. And those current solutions are supported by Barracuda, and then the brand new one is Cisco Viptela. What makes these solutions unique is it is a fully managed offering from Microsoft and the third-party partners. So it supports a scenario where you don't actually manage the Barracuda or the Cisco Network Virtual Appliance. However, you still get all of the provider's proprietary features. So if you have an existing Viptela deployment or a Barracuda deployment within your organization, and you like a lot of the features that either one of those solutions gives you, you can actually deploy that directly into your virtual hub and still get all of those features without having to worry about managing the specific NVA, right? All of that resiliency is handled for you by Microsoft. And all of your routing capabilities are still handled directly within the routing of the virtual hub versus having to go into the specific appliance itself. So putting it all together, connectivity options, express route, point-to-site VPN, site-to-site VPN, virtual network, and then for security, we have our secured virtual hub with either Azure Firewall or one of the supported partners. Ultimately, VLAN scale is unmatched as compared to the standalone options. So if your organization or your clients, when you're designing your Azure environment, also specifically with enterprise scale landing zones, Azure Virtual WAN has the scale that far exceeds their individual options. So depending on whether you need 200 gigabits of throughput for point-to-site users or that 100,000 end user capability, or if you have a multitude of smaller branch office locations that you need to have VPN connections directly into Azure, or you need that higher aggregate throughput for your various express route connections, Azure Virtual WAN is going to deliver the scale that you need to help manage your networking within Azure at a much greater operational efficiency level versus your standalone network gateways that you might see from a traditional Azure networking perspective. Ultimately, what makes VLAN very unique are a lot of those firewall managed partners, so your checkpoints, your iBoss, and your Zscalers. That connectivity automation that you get with site-to-site VPNs, again, all of those partners have a automated connectivity model within Azure Virtual WAN that you can use to automate your site-to-site VPN connection deployment within your SD-WAN type solution. Your point-to-site VPN users, that traffic manager that I talked about earlier that gets fronted that you don't see, you only see that within Virtual WAN. You don't see that within a traditional virtual network gateway model. So that is an advantage as you're trying to load balance point-to-site users connecting into your Azure environment. You will get that traffic management option only within Azure Virtual WAN. And then ExpressRoute encryption, being able to set up that VPN tunnel directly over ExpressRoute is only available within Virtual WAN. All the hubs are fully meshed. So no matter where you deploy your hubs within your Virtual WAN, they are automatically connected unless you deem it otherwise. And I can show you where you can actually turn that off if you don't want fully meshed hubs. However, I strongly recommend that you don't do that. That's one of the best advantages of Virtual WAN, as having that hub-to-hub capability. And here's just kind of some of those traffic patterns that you can expect from a Virtual WAN perspective. So whether you're going from ExpressRoute into VNet, VNet to VNet, branch to branch, ExpressRoute over to VPN, branch to branch over various regions. So I could have a point-to-site user in one region, and they can connect to my branch office located in a different region over their Virtual WAN environment. And I can also connect to virtual networks not located in my home region over Virtual WAN. And then if I have a secure virtual hub, I can get access to the internet directly from either my virtual network or my remote sites or my remote users directly through Azure. Vlan pricing is handled a little bit differently. There are a couple of things to take into consideration. So the virtual hub itself has a scale unit cost. So the higher you scale up in aggregate throughput, the higher the cost. So something to consider when spinning up the solution. And then you also have a cost for number of connections, at least when it comes to point-to-site users. For the firewall, same cost kind of applies from that perspective. It's a per hour per gigabit charge. And then from an internet bandwidth perspective, only the traffic that is egress or source destination based is charged from a Microsoft perspective. All right, so one of the fun, or at least more challenging parts of Azure Virtual WAN is configuring the routing within Azure Virtual WAN. The reason being is understanding the custom routing capabilities, marrying them with the default or standard routing capabilities that applies to your branch locations. And what makes this unique is you can apply any number of custom routes to your virtual networks. Unfortunately, that capability is not available to your branch locations. So whether it's site-to-site, ExpressRoute, or point-to-site, all of those are treated under a single umbrella from a Microsoft perspective. Now, all of your connections, whether they be VNet or branched style connections, can learn the routes associated with their associated route table. So say, for instance, I have all of these various IP locations that you see down here at the bottom. But the default route table that gets associated to each of these branch locations will learn the networks that are available to them. And then on the flip side, if I apply that same default route table to my VNet connections, the branch locations will also learn about the VNet connections that you see. And it can be 1 VNet, 2 VNet, 10 VNets, it really doesn't matter. And then that works in the opposite direction as well. So my VNet connections will learn about my branch locations via this default route table. And this is the standard approach when it comes to Virtual WAN. You get the default route table by default, which is what supports this any-to-any connectivity option within Azure Virtual WAN. However, most organizations are more than likely not going to support or at least be comfortable with an any-to-any type connectivity model. And so typically we as Azure architects will go in and have to modify the routing capabilities and apply some custom routing tables directly to our virtual networks. Now, only the Vnets can be associated to custom route tables, and you populate those route tables directly with your Vnet connection IDs. You do have the capability of adding static routes directly into your route tables. However, typically I only recommend this is if when we get to a specific routing situation that involves network virtual appliances, which we'll talk about here in just a couple of minutes. Now, from a routing rule perspective, the route tables works very similarly to some of the user-defined routes. So the more specific route that you have, that's the route that is preferred from a routing perspective. So when I add, say, like a third virtual network connection, and maybe I need to, have a generic route, you can super route your on-prem locations if they're all contiguous. So in my instance right down here, because everything is .1, .2, .3, I can establish a new route for that and using the /16 moniker. However, if I were to spin up, say, a new on-prem location and I have that as like a .4 and I put that in as a specific route, that one actually would be preferred over this super route when applying a routing coming out of my virtual network that is associated with this route table. So right here in VNet 1. We'll talk about why I would add the 10.3.0.5 when we get to the specific NBA use case. So our first custom use case situation is if I want to isolate my virtual network, so no transitive routing capability. So in this situation, we would have just the default route table and maybe one custom virtual network route table. And the way you would isolate these two is by simply not propagating each of the virtual networks into the route table. So the way you would do that would be from a default route table perspective, you would add the virtual network connection IDs into the default route table, so your branch locations could reach either of the virtual networks. However, within the custom route table, you would deliberately not add either of the VNet connections within this route table. So the only thing you would see within that particular custom route table would be your site-to-site connection ID as well as your express route connection ID. So your Vnets would have no idea how to get to each other within this route table. They would only know how to get to your on-prem locations. Now, our second use case is what if you had something like a shared service Vnet? So within, say, your organization, you might have a shared services Vnet where there are DNS servers or domain controllers or any number of services that might be shared. So from that perspective, we would add that third virtual network within our environment to our virtual WAN hub. And then we would just need to ensure that the default route table is listed with that third virtual network connection ID, along with our two standard VNet connections. And then we would create a second route table that would add in that third virtual network. Now, typically within a shared services VNet is where we might have that network virtual appliance that can allows the connectivity to reach our shared services. So in this instance, this is when we would add something like a static route into our route table. And how that would work is we would define that endpoint as a static route entry within the virtual network connection as the gatekeeper into getting to that virtual network. So when we go through our route table setup, when you put in your network connection ID, there's a you would then proceed on further to say, hey, I want to add a specific endpoint, and then you would add in that static route of a 10.3.0.5 as the network virtual appliance that handles all of the routing within that virtual network connection ID. Now, what if we have, say, multiple virtual networks that need to be isolated from each other? So the interesting use case that gets presented is you would have a VNet in one region that can talk to a VNet in another region, but it can't talk to some other VNets that are located in different regions. So in my use case, right, blue can talk to blue, orange can talk to orange, but they are not allowed to talk to each other, but they still need to reach all of the various on-prem locations. So this is when we would bring in a unique concept within the route tables called labeling. Labels allow you to associate or share routes among various route tables that you have within Azure Virtual WAN. So by default, you're given the label of default, and that's obviously associated with the default route table. However, when you spin up multiple virtual hubs, that label will then carry over to your other default route table within your Virtual WAN instance. So you can see here that I would have the different site-to-site as well as express route connections, all associated with the default route table, and that label gets associated with the other default route table for my other Virtual WAN hub. Now, for our custom use case, I would create two new labels, specifically one for my blue VNets and one for my orange VNets. And what this does is then allows me to have a specific network connections for just my blue VNets and just my orange VNets. And so anytime I apply that label of orange to any additional route tables that I might add on to this particular use case, they automatically get these existing VNet connections or these existing routes that I've created because they're associated with this specific label. And then obviously from our routing perspective, our on-prem locations would be able to see all of the virtual networks. That any-to-any connectivity from a multiple hub instance looks very similar. So individual default route tables, however, because they get that label of default, you can see here that we get all of our virtual network connection routes propagated between the two route tables, even though they're both defined as a default route table. Because of that label default, they get shared across the various virtual hubs. Now, if we add in the Azure firewall to our virtual hub, a lot of end users wonder, how do we handle routing from that perspective? So the unique trick here is typically from a design perspective, we want to have internet traffic exit the Azure firewall. The reason being is the Azure firewall at the moment doesn't support hub-to-hub inspection of traffic. So in a multi-hub situation like we see here, we would want to make sure that the VNets within the region that you see the secure virtual hub actually exits the internet directly from its local firewall. If I'm having traffic go from, say, VNet 1 hitting this secure virtual hub and then transiting over to this secure virtual hub, that traffic actually does not get inspected. It just bypasses the firewall, which is a current limitation. I do expect Microsoft to address that at some point, but just know that from a design perspective, if you have multiple secure virtual hubs, traffic does not get inspected as it does the transitive routing to the other region. So typically we want to make sure, at least in this use case, the internet bound traffic exits the local firewall that's within the region versus maybe a centralized region that you may want traffic to exit. But from there, you want to make sure that you add in that quad 0 route directly into your virtual hub route table, specifically the default one, so that each of the routes know to exit their local table. Now, That NVA use case that I demonstrated earlier from a shared services perspective, I didn't necessarily address what happens if you have other virtual networks sitting behind that NVA. And so from that use case, what if we added in a couple other virtual networks, maybe that sit behind our shared services VNet? What would that look like from a routing perspective? And the challenge here is Virtual WAN actually cannot control those tertiary VNets from a routing perspective. So this is where we would need to come in from an architecture perspective and add in user-defined route tables. So from a virtual WAN routing perspective, your VNet connection would still get that static route for the NVA, but your indirect spoke virtual networks would actually have a user-defined route directly to that shared services VNet. And then you would put in that static route connection into your custom route table. So as you can see here, at least from within my route tables here, I've added in the 10.2 and the 10.4, and the next hop is those VNet connection IDs. And then I would put in that NVA IP. So whether it be a NIC on that NVA, or if it's a load balancer that's fronting an HA pair of an NVA, whatever that IP is that is fronted by the load balancer or the static IP is you use for traffic to come in and out of your NVA, that would be the one that you add in for your static network connection. And then from a routing capability, you would actually see your indirect spoke VNets handle their VNet to VNet transitive routing through that NVA, or even transiting out the internet through that NVA. But if you were coming in from on-prem and going to one of those indirect spokes, you would transit through the virtual hub, through that NVA, and directly onto those indirect spokes. So within the portal, when you set up a route table, you'll see something similar to what's on my screen here. By default, right, we have that default route table. Now, one route table I didn't talk about is the none route table, but I will talk about that one at the end. But those are the two that are always created by default anytime you spin up a virtual hub. And then from there, you can go ahead and add in any of your custom route tables using that nice little button you see at the top that says Create Route Table. The first thing you'll see pop up when you hit Create Route Table is this little interactive setup, much like any other Azure service. You need to give it a name. The name does not have to be globally unique. It just has to be unique within that particular hub instance. Typically, a naming convention is usually RT underscore whatever you would like to name it. That's just necessarily my own personal private naming convention practice. You don't necessarily have to follow that one. You can kind of name it whatever you so choose, but do understand it just needs to be unique within the instance itself. From here, you'll give your route a name, what type of destination type you're using. More often than not, you are going to use CIDR notation, but you can use FQDN notation if you so choose. You'll put in your destination prefix, so whatever your network destination is, you put in that there. So the more specific you are, the higher you are up on the routing preference. And then the next hop is your defined connection that you have within Virtual Hub. So whether it be a VNet connection or one of your branch connections, you'll define that next hop in here. Now, if you want to go ahead and add in that static routing option that we talked about earlier, that's where you see this little next hop IP, and you'll hit that little configure button, and you'll put in the specific static address for that NVA in order to allow your traffic to route to that specific NVA, and then even beyond the NVA onto either your indirect spokes or a specific shared service. The next section is those labels that we talked about earlier. So setting up a label allows you to propagate those routes across multiple route tables. So in our previous instance, right, our labels were blue and orange. So as I add maybe additional blue Vnets or additional orange Vnets, right, because I have associated a label with that route table called blue and the other one with orange, I can propagate all of the routes that are learned by blue Vnets to any other route table that has the blue Vnet label without needing to set up any manual configuration. The next section is your associations. So this defines which route table or which virtual network connection gets the route table associated to it. So associations are connections that will learn routes from the route table that's been assigned to it. So you can use one route table, two route tables, right? You don't necessarily have to have a route table individually assigned to every single Vnet. You can just have one custom route table and associate that to multiple virtual networks if you so choose, depending on your routing needs. Unfortunately, that's not the case with your branches. They only get associated with that default route table. You cannot individually assign them. And then finally, the last section is propagation. This is our dynamic routing capability. So within propagating, you can define where that route table will learn routes from. So you can choose to propagate your on-prem or branch site locations if you so choose. You don't have to. You can select that option as no if you want. And then you can also decide as to which virtual network connections will propagate directly into this custom route table. And then once that's created, you can actually then go into the effective routes section over on the next little side that you have within your route table area. And then you select the type or the route table you want to view your specific effective routes, and then you'll get a nice little spit out of all of the various routes that are associated with that particular route table, what its next hop type is, where its origin might be. So very similar to what you might see from a effective routing on a virtual network interface. Very similar. You'll just see maybe some different options, right? So you would probably just see either a remote hub. If you have multiple hubs, you'll see your various gateways, whether they be express route or site to site or point to site, or if it's going into another virtual network connection. So in summary, when it comes to routing, all of the connectivity models, site to site, point to site, express route, those are all considered branches as it relates to Azure. You can only associate and propagate to the same set. So you cannot individually associate express route to a particular custom routing table and not do point to site and site to site. It doesn't work that way, unfortunately, within the current configuration. So do please keep that in mind. If there's a reason for you to need to isolate a certain branch type of connection, you can't currently do that within Azure Virtual WAN today. Custom route tables are only supported for virtual networks. I believe Microsoft that's been a feature request for quite a while. So I imagine the product team is working on that, but there obviously are some challenges. So I would eventually expect to see that capability added to Virtual WAN sometime here in the near future. Connection associates to a route table. So understand that when you do an association, you're expecting to learn routes from that route table. Propagation, you're expecting the route table to learn routes from that connection. So there's just a slight distinction between those two. Specific routes always win, right? So the more specific of a route that you add, it will be higher up on that routing chain as compared to ones that are less specific. It does not matter the order that you put the routes in when it comes to a custom route table. So even if I define, say, 10.1.0.0/24 as my first routing entry, if I have 10.1.0. Let's say 32, and add in, let's say, like a /28, right? That route will win over the /24. You can set up more specific static routes if you need a next hop as a particular firewall or an NVA. So you'll define whatever VNet that NVA lives in first with that VNet connection ID, and then you'll set up the specific endpoint as a static route within the route table. And then you can view any effective routes directly in the routing section on your virtual hub, and that is per route table. And then finally, and I promised that we talk about the none route table, anything that is selected to propagate to the none route table, essentially consider that a black hole. It doesn't get it doesn't get learned, it doesn't get associated. So the none route table is essentially where routes go to disappear or die. So you can use that in your routing arsenal. If you don't want specific Vnets to learn routes, you can associate that or propagate that Vnet connection into the none route table, and then you can effectively consider that a black hole and it will never be learned. So next steps, we'll go into a little quick demo of Azure Virtual WAN within my own environment. But I do highly encourage you to spin up your own Azure Virtual WAN lab. Particularly, there are a couple of good ones out on GitHub. My preferred one is the one listed here. This allows you to spin up Virtual WAN on your own via Azure Bicep and some Azure ARM templates. And it'll create a multi-secure hub environment for you. And you can kind of play around with setting up firewall policies, kind of see what the traffic patterns are with the two different secured hubs. And then it also places a couple of Azure virtual machines in your environment, one on the Vnet side and then one to quote unquote act as your on-prem side. So you can kind of see how the traffic patterns apply from that perspective. And then the other action that I encourage is you can learn more about Azure Virtual WAN either through, and you can tell I forgot to update this particular slide, through the Azure Solution Architect Expert AZ303, which will effectively die out here come March of next year. So that actually is now within the AZ104 or the Azure Admin exam. That one will be a little bit more basic from a learning perspective. The more deeper Virtual WAN is now within the AZ700 or the Azure Networking Engineer Associate learning path. All right. Let me hop over into my portal here. So creating a virtual LAN is pretty easy. Literally go up into the virtual LANs, you just hit create. As you can see here, there's only two things to do. So you just need to define a resource group that it needs to exist in. You can give it a name. By default, it will inherit the resource group location as the location to store the metadata for your virtual WAN instance. There are two types of virtual WAN, basic and standard. The main difference between the two different SKUs is basic is site-to-site VPN only, and it does not give you any transitive routing capabilities within basic. So it's great for kind of a very plain POC setup. So if you're labbing this at home and you don't necessarily need to play around with point-to-site or express route or VNet to VNet transitive routing capabilities, you can use basic. Otherwise, all of the other features are only available within standard.
Derek,
yes.
Alex was wondering if you can zoom in a little bit.
I can zoom in some more as I can. Sorry, I know I'm on a 4K monitor, so I apologize.
No worries, thank you.
All right. You can upgrade from basic to standard. Hopefully that view is better. You cannot go the other way, as with other Microsoft services. So once you upgrade from one SKU to the other, you cannot reverse that action. You would need to spin up a brand new Virtual WAN instance. Once you do that, you just review and create. The process takes not but just a few minutes, but the good news is I already have an instance created. So we'll just go ahead and click into my instance here. So for this particular use case, I deployed mine into West Europe. And when you select overview, you get, kind of the standard view within Azure Virtual WAN. You'll see that its location where you deployed it, its status, whether branch to branch is enabled. So I talked about earlier is while I would always strongly encourage you to have branch to branch enabled, you can actually turn that off. So if it is turned off, you would see that right up here and it would say disabled. It lets you know how many virtual hubs you have, and then you can also view your topology. So if I were to click that, you're going to see this lovely view here. And I don't have much in my demo, so there's not a huge topology, but in a normal environment, you would get the nice network topology view of all of the various hubs as well as the various VNet connections that would be associated to your various hubs. And so this will be a nice little network printout. So within that configuration under settings, I talked about you can disable branch to branch. You literally can do that right there. Click that off, and this prevents any branch to branch connectivity. The upgrade option, if you need to upgrade from basic to standard, that's done right here as well. You can see mine's grayed out because I'm already at standard. And then it gives you the nice little overview of the differences between basic and standard SKUs. As you can see, basic, again, supports only site to site, branch to branch, and branch to VNet. It doesn't do VNet to VNet. So if you need any of the VNet to VNet capabilities, point to site, or express route, you will have to upgrade to the standard SKU. One thing I should note when it comes to express route, if you do have multiple express routes within your Azure Virtual WAN environment and you want express route to express route connectivity, you will need to make sure your express route has that global reach add-on. Azure Virtual WAN does not support express route to express route transitive routing by default. It does leverage the global reach capability. So when designing the solution, do keep that in mind from that perspective. I very rarely see that when I do my deployments. Typically, it's usually express route to VPN is what I see from my perspective. But I have had a client or two that maybe has a data center in one part of the United States and has another data center located in a different region. And so in order for those two to perform their transitive routing, we had to add in the global reach capability. So within here, we can spin up any number of various hubs. One hub per region is all that's allowed within an instance. So there, and for this instance, right, if I were to go in here and create a new hub, I couldn't choose West Europe as my region because I already have a hub within that region itself. So you can see here, if I were to go in and select West Europe and then give it a name, test hub. And then through this creation process, and I'll get to the end and I'll show you where it'll fail. But within this, actually, we'll just make sure it doesn't fail. I'll just slide up here and choose, let's go to Norway East. So you can see here, pretty much all of the Azure regions support Azure Virtual WAN, including some of the newer regions. So West US 3 is at least the newest region in my area. You can see South Africa is in here. That's a relatively new region. So it, by default, as new regions get added, Azure Virtual WAN typically can support them relatively quickly. So if Microsoft is spinning up a new data center in an area that you're really eyeing, don't fret. More than likely, it'll pop up on this list relatively quickly. Name just has to be unique within the instance. Your hub does need a private address space. I typically, as a best practice, always assign a /24. I've seen others assign a smaller network space. I don't typically recommend that, just from a scalability perspective. If you ever decide to add various gateways into your virtual hub, and depending on the amount of traffic that you might have flowing through, a /24 is recommended as a best practice. And then from here, you can spin up all of the various gateways. So much like you would do on an individual perspective. We talked about those gateway scale units and kind of how the pricing works. So as you can see here, you see the various individual scale units going all the way up to 20. And you're probably seeing this here, and it says, hey, I thought you said there was 20 gigabits of aggregate throughput. This says 10, but you notice right here, there's that ×2. So Azure Virtual WAN does deploy 2 instances of the gateway by default. So there's a natural HA with Azure Virtual WAN that you can connect to from a network design perspective. And then I'll show you what that looks like here in just a minute. So that's where the 20 comes from, is there's 2 different gateways that handle that capability. Obviously by default, 65.515 is its assigned BGP ASN. That's standard throughout Microsoft. And then depending on your routing preference, you can specify whether you want to use the Microsoft network or the internet. Personally, I recommend the Microsoft network. Point to site, same thing. As you can see here, all of the various scale unit options all the way up to that 100,000. But I do like this one because it does tell you by default how many clients it supports. So depending on how many end users you know you need to support, this one gives you at least a nice little gauge on what scale unit to select from a end user perspective. And then you would set up your normal point to site configuration, the address pool you would like your clients to use. And then you can see right here the custom DNS server options. So if you want to add in your own DNS servers, you would do that right here within this. Note that there's only up to 5 DNS servers that are allowed. So depending on your network configuration, just know that you're limited to that capacity. And then express route, same thing. Scale units are pretty standard, 1 through 10, 10 being the maximum of 20 gigs. It does take 30 minutes, as you can see down here, a little notes. So in the efforts to save time, I have mine already set up. So once yours is configured, you'll come up into a screen much like that you see here on my screen. Now, depending on the type of gateways that you added, you'll see these populated within this instance. So if you created one with VPN, you'll see an option of a VPN gateway already being populated here. If you decided to add in an Azure firewall or one of the network virtual appliances, you'll see those boxes drop down and have a population within there. From here, within your hub, you can go ahead and jump into any of the various connectivity options. So whether it be VPN Express Route, we already walked through the routing, but that's where you would find your routing is directly within here. If you do want to convert your virtual hub into one that does have a firewall, you can do that under the security option. So you can just go ahead and tell it, hey, I want to convert it into a secure hub. And then you have the option to add in your Azure firewall. It does support both the standard and the premium version of Azure Firewall. So whichever one you would prefer to use, you can add that into your virtual hub, or if you want to go ahead and add in one of the security partners, you would do that from here. You can select either of the three that are currently available. Just make sure to check out that integration guide as you go through and follow along with their specific documentation. And then if you want to add in the virtual appliances, again, you can do that right down here from that perspective. When you go to connect all of your virtual networks, that'll be down here at the bottom. As I wait for the mystical 3 blue dots to go ahead and populate. As you can see right here, I do have one virtual network currently connected, and I do have a custom route table associated with that. So when you go into this type of connection, you'll give it a name, much like you do, say, a peering. You'll assign it to a specific hub. And then when you go to look for a virtual network connection, you'll select the resource group it's located in. And then down here at the bottom, you can actually go ahead and configure the routing capabilities for that virtual network connection if you so choose. You don't have to, but it does if you already have a route table created and you want to automatically go ahead and select it. You notice here that the option to propagate the routes from this virtual network connection, you can select to none, and that'll automatically gray all those options out, and you would just select the none route table. So if you want this VNet connection to be completely on its own and not be able to learn any routes from any route table, you just go ahead and select that option. If you don't want to do that, then you'll go ahead and choose your route table, and then you can choose which route tables you would like to propagate this network connection into. So obviously I can choose my default or my existing custom route table. And then if I have any labels defined, right, so I can choose my custom label. And then any static routes, so if this is a particular spoke VNet that might have a NVA, I can add in that destination. Okay, so I can find that as 10.0.2.5, right? And I can add in that specific IP that would be associated with this particular VNet. And then from a monitoring perspective, you do have two options directly within the Azure Virtual WAN instance. You can set up a connection monitor. So if you have a particular virtual machine, you want to monitor return traffic to and from, you can set that up as you would typically within Network Watcher, but it's actually done directly here within Azure Virtual WAN, or you can take advantage of the new Network Insights capability. So we saw this network diagram earlier. So you can do all of your topology and network troubleshooting directly from the new Insights capability. And so they've actually integrated that directly into Azure Virtual WAN. You do not have to go into Azure Monitor to do any of your monitoring and or troubleshooting. You can all be handled directly from within the Virtual WAN interface, which is one of the reasons why, from a operational perspective, it is a very powerful resource to set up for any organization. All right. So I'd like to thank everyone for taking time out of their day. I hope you guys learned a lot more about Azure Virtual WAN. I do obviously encourage you guys to go and set up your own demo and give it a try. One of the best use cases I find for Azure Virtual WAN is the enterprise scale landing zone and that hub and spoke architecture. The reason being is obviously Azure Virtual WAN supports that out of the gate. Feel free to connect with me on LinkedIn or Twitter. You guys can see my handle down there at the bottom.
Awesome. I actually see that we have a few questions.
Right.
If you have time, I can read
Absolutely.
3 or 4 questions. So the first one was from Richard. He asked, would it be a good idea to start designing and deploying Virtual WAN instead of doing traditional Vnet peering for customers that are transitioning to Azure?
It depends on the architecture that you're looking to deploy. So like I said, if I am setting up more of an enterprise scale type environment for my customer, yes, I would absolutely set up my customer with Azure Virtual WAN and set up the peering through the Azure Virtual Hub. If my customer has more of a flat network architecture, maybe 1 to 2 Vnets, then obviously peering would be a more effective option from that perspective. But typically, most customers, right, 3, 4, 10 Vnets, however many they particularly have. Yeah, I would lean towards Azure Virtual WAN as being kind of my default option from that perspective. But yeah, if I have a relatively flat network or my client or customer is only going to have 1 to 2 virtual networks, right, really small environment, obviously I would leverage peering in that instance. Yeah,
I agree. I also started using it at a couple of smaller deployments where the customer have maybe 4 or 5 Vnets, but they have like 30 branch offices that they want to connect. So we used Vlan in that setup, and I think it made it much more easy to handle all of the routing and the setup.
Yeah, no, definitely. That's its probably best use case, right? User-defined routes are a headache, and so having the ability, I think, both to create route tables and dynamically handle routing from that perspective, not only eases the operational burden on your client or your customer, but it eases the setup on you. And a lot of traditional networking folks will understand your architecture and your routing more so than from a user-defined routing capability. So I found where I have implemented Azure Virtual WAN and set up that routing, whether it be from VNet to VNet or on-prem to VNet, the network team follows along a lot better when I implement Virtual WAN versus if I use a more traditional hub and spoke with various peerings, right? And I have all these route tables with user-defined routes kind of scattered all over the place. The networking team tends to get more testy and doesn't quite understand the topology, and they kind of struggle from a routing perspective in that way. But so if you have a client that you're working with and their networking team is kind of struggling to follow along, Virtual WAN would probably be a much better solution in that instance, because ultimately, right, unless you are going to be managing their environment for them, we want to leave them in the best position to be successful. And so Azure Virtual WAN, because of its more dynamic capabilities from a routing perspective, is going to be a much easier transition for those folks to learn and understand how their environment is networked together and where the various routes are going.
Right. Makes sense. Also, we have a question from Jimmy. He asked, in your experience, how is day-to-day operations usually handled for Virtual WAN deployments, portal or infrastructure as code?
Typically, in my experience, if everything is deployed correctly, it's going to be infrastructure as code. And the reason why I say that is if all of the routing, and obviously this takes a decent bit of planning up front, but all of the routing is set up correctly when you deploy your infrastructure as code for Virtual WAN. More often than not, you're never going to go into Virtual WAN to really look at anything unless somebody is raising a ticket or an issue. And in that instance, right, if somebody does raise an issue, or somebody's complaining about not being able to reach something, yes, obviously you're going to go into the GUI, look into your insights and see, is there some type of broken connection, or go in and view those effective routes to see maybe if something got missed from a deployment perspective. Maybe a route didn't quite make it into the route table, or association didn't quite take, or something of that nature. But for the most part, from an operational standpoint, I try to leverage as much of infrastructure as code as I can, and then only worry about using the GUI when I need to either monitor something or troubleshoot an issue that may have been raised through my ticketing system, or other ITSM that somebody might be using.
Yeah, I have the same approach. Prefer the portal for initial setup and exploration and labs and so on, but for production, when it's properly planned, infrastructure as code is really preferred, both regards to automatic documentation, change history, and all of those benefits as well.
Yeah, absolutely. And the good thing is I find now, I wasn't the biggest fan of ARM, at least ARM templates in a Virtual WAN instance, but when it comes to Bicep in Azure Virtual WAN, it is much easier. So if you are looking to do infrastructure as code with Virtual WAN, I would lead with Bicep. It is less prone to errors as compared to ARM templates, and I think that speaks to the fact that because Virtual WAN came later, and they had to, it was a relatively new service. It's there in ARM templates, but it's not very readable, and I find people struggle to kind of understand what's being deployed and kind of where things are. Bicep does a much better job from a coding perspective, showing you exactly what you're doing, what you're deploying, what type of route tables you're associating, what type of virtual hubs you have, things of that nature within Bicep. So I strongly encourage, if you're doing infrastructure as code with Virtual WAN, go down the Bicep route. You'll be much happier versus ARM templates.
Yeah, the authoring experience with the VS Code and the Bicep extension, it makes it much more easier than ARM templates.
Yeah, and a lot of the people who are giving out some of those Virtual WAN playgrounds within GitHub, they are adopting Bicep. So a lot of the stuff that you're going to see from a POC perspective, or if you want to leverage some of their code, it's all going to be in Bicep. So you're it's going to be better off from that perspective.
Yeah. Then we have a question from Rune. He asked, is it any setup or SKU that do not support branch to branch?
Sorry, could you read the question again? I apologize. I heard not branch to branch.
Regarding the SKUs, are there any SKU that do not support branch to branch?
So both support branch to branch. The only difference is on the basic SKU, you're only getting branch to branch from a pure VPN play, whereas with the standard SKU, you get branch to branch across all of the 3 connectivity options. So VPN, point to site VPN, and ExpressRoute. The only one that's not supported from a branch to branch connectivity model without additional setup is ExpressRoute to ExpressRoute, and that's where you would need that global reach add-on capability. So yes, by default, branch to branch, basic SKU, standard SKU is there, but you can go into the configuration and disable branch to branch. So even if I'm in the basic SKU and I have my various VPNs and I don't want branch to branch, just go into your Virtual WAN instance, and in that configuration, just set it to disabled, and you can disable any branch to branch connectivity. So that option is there irregardless of whether it's basic or standard. You can turn it off if you don't want any of your branches talking to each other.
Right, thanks. And then Richard asked, site-to-site gateways, they are deployed as an active HA pair?
Oh, yes, they are. And I just realized I never showed you that. So yes, they are deployed as an HA active pair. And each of them has their own public IP as well as private IP. Let me go back in and I will show you that. I apologize.
So from the on-prem device, then you need to connect to both of them, or is it sufficient to have only one if you don't?
Yeah, it depends on the type of architecture you would like to set up. But yes, typically from an on-prem setup, actually I don't have my virtual network gateway deployed in here. But yes, there is, let me see here. It's going to take 30 minutes. I have another instance of it somewhere. I'm trying to think if there's an easier way to show. But yes, sorry. By default, and I apologize, I thought I had a VPN gateway created. So yeah, HA by default from your on-prem device, yes, you do need to connect to each of the gateways separately. So when you go to set up those VPN tunnels, there's an option to download the VPN configuration from the virtual network gateway. And in that connection, there are going to be what's labeled as instance 0 and instance 1. And those will be your different instances of your virtual network gateway. Each of those public IPs will be unique. And then depending on the IKE settings that you have for your virtual network gateway, those will be the same. So you won't have to worry about that. But yes, the endpoint that you're connecting to will be different.
Yeah, perfect. And then we have the last question of the day from Mats. He's wondering, are there any method of governing default custom DNS servers for connected Vnets via Virtual Hub as opposed to setting it in the individual Vnets? Or do you know whether this is on the roadmap for the product?
I'm not aware of it being on the roadmap for the product. I'd have to reach out to the product team and see. But yeah, unfortunately, as of right now, if you need to set DNS for the individual Vnets, you would still handle that traditionally, right? I would go into the virtual network and set custom DNS from that perspective. The only thing that Azure Virtual WAN manages from a custom DNS perspective is the DNS that your end users would use from their VPN perspective. So if I, as an end user, spin up the Azure VPN client and I tunnel into my virtual WAN instance, right, it will present me with those custom DNS servers that I put when I spin up my virtual network gateway instance. Outside of that, the individual VNets themselves, you'll control DNS still within your VNet options, not within Virtual WAN.
All right. Yeah.
Hang on. Is it a better option? Oh, hang on. Is it a better option to use Azure Virtual WAN to route internet traffic via a shared VNet or make other VNets private in an enterprise landing zone? Again, it's going to be subjective. It depends on the architecture and what either you prefer or your client prefers. Typically, I prefer to route internet traffic via either the hub or a shared VNet if I have a third-party NVA that isn't supported from a virtual WAN perspective. So I'll pick on Palo Alto. So if I have a Palo Alto firewall that I want to manage my internet-based traffic, right, I will route internet traffic through that shared VNet, whether it be my Vnets or my on-prem, if that's the type of model that my client or the architecture supports. Otherwise, right, I would make sure to route traffic either out the virtual hub if I can make it happen, either through Azure Firewall or one of the security service partners. In a rare instance, there has been a client or two that has wanted traffic to be routed through on-prem. So you can do forced tunneling back to on-prem through the Azure Firewall or through Azure Virtual Hub. It is a networking mess from that perspective. So I don't typically recommend that type of routing option when it comes to virtual WAN, either internet out the virtual hub or internet out a shared service VNet. NVA is definitely a preferred model, and you're going to have less headaches from an operational standpoint.
Perfect, thank you. I think we'll wrap it up here. Thank you so much for your time and also taking the time to answer all of the questions. So I'll go ahead and stop the recording at this point.
All right, thank you.